Good morning. Thanks for showing up. I know you guys had, it's good? Okay. So I know you guys had a party yesterday evening. I'm glad you all showed up. Uh, First day, Saturday morning, 9 a.m. I know it's very hard, but thanks for showing up. Just to set expectation, this session is all about SQL DB data portability. Uh, it's an introductory session. I know there's a lot of technologies, a lot of options that we have. We'll give you a quick rundown of what it is, cover some new things which are coming in this area, and then keep you excited. So we'll make sure that your time spent here is valuable. Quick introduction. My name is Rajesh. I'm a principal PM manager focusing on business continuity and data virtualization. And today I have with me Carlos.
Hey, my name is Carlos. Thanks, as Rajesh says,
Yeah.
thanks for joining us today. And I am a product manager in the Azure Data team. I'm part of the SQL Developer Experiences team. And we're very excited today to talk about data portability in Azure SQL Database, as I just said.
All right, so we'll get started. Before I get started, just a quick show of hands. How many of you are DBAs? Good. How many of you are developers? Okay, that's a good mix of good mix of DBAs and developers. How many of you had dealt with data portability scenarios? Okay, so pretty much everybody in the room. So I mean, as the nature of the job evolves, whether you're a DBA or a developer, you are supposed to deal with data portability, meaning moving data from one environment to another. So we'll talk about all the options here. So one slide, we'll talk about at a high level overview of what portability is all about. I know pretty much you know everything, you have dealt with it, but I just want to make sure we level set. And then we'll talk about those four technologies. We'll talk about import export, data sync, CDC, and fabric mirroring. Mirroring just gets really exciting because of all the fabric investments that we are making and the investments that we are making to connect your OLTP with fabric. So that will be really valuable. So with that, let's get into what is portability. So this is your ability to move data from one environment to another. And here the unit of movement changes, right? We all know how to deal with databases. Good old on-prem databases, you take backup and you restore. When it comes to cloud, there are certain nuances, especially with SQL DB, because we don't support the native backup and restore on SQL DB. So that's when you have all the other options, right? But the unit also changes. Like someone could say, hey, I don't want to move my entire database. Can I go granular? So that's when you have options to move to tables or even rows, right? Which is where all the other technologies will come in to help. And there are different tools. We are Microsoft, so we'll give you a lot of tools for different purposes and let you figure out. But I'll give you a quick overview of what each tool is meant for and what it is not meant for. So that way you use it exactly for what purposes it's intended to. And use cases, right? When we talk to customers, a lot of them have use cases for migration. With SQL DB, with the lack of native backup restore, some of these tools have been used for migration, which is okay. But then as we get into a bigger DB sizes, those fall flat on the face, right? So those things we'll talk about it. Validation, people use it for dev test validation, refresh from prod to dev, and for replication into different scenarios, right? So they want to keep one environment, take the data out, and then get it down to a lower environment. Or they have some use cases where they just want to specific data from a specific table to go from one environment to other environment. So these are all the different use cases. And some of the things that you will notice is there are technologies that allow you to do from on-prem to Azure, or Azure to Azure, or from Azure to on-prem to. So these are some neat technologies that you can mix and match with currently with what you have, right? All right, so let's talk about import export. How many of you have used import export in SQL DB? Okay, how many of you absolutely hate it? Unfortunately, that's the reality, but we are trying to, I don't want to promise anything that will not come up in the near future, but at least we are thinking to make sure how can we make this robust. So towards the end, I'll talk about our plan on what technologies that we can use to make it really robust. So before, for a long time, I always had this confusion between backpack and DACpack, right? I mean, I was a DBA for a very long time, and then I pretty much dealt with most of the time backpack. As the name suggests, it's a backup. It's a backup package, and it involves both schema and data. That's easy to understand. But for DACpack, how many of you deal with DACpack? Yeah, all the developers, you know how to deal with DACpack, right? So that's pretty much only for the schema, right? And the thing that always developers always used to deal with is the DACFX APIs. So this is this is an entire end-to-end application lifecycle management framework. So that lets you deal database as any other developer object, right? I mean, you can have version controlling, you can integrate with Git and do a bunch of other stuff. But we exposed APIs that support both Backpack, which is taking the data plus schema, and for DACPack, right, where you can extract a database, store it in a schema, do version controlling, and then deploy it from one environment to other environment. So does that help explain difference between DACPack and Backpack? And if you look for what's it's used for, right? Backpack is used for export and import, do migrations from one environment to another. DACPack, pretty much integration, right? You develop in one environment, create a DACPack out of it, and then you deploy it from your test or dev into your prod, right? One thing that I want to highlight is towards the end is this notion of not using the Backpack for replacement of backups. SQL DB is a PaaS service, so we take backups for you right out of the gate. But we don't expose those backups. So what I've seen is some use cases where customers use Backpack as an option to build their own homegrown backup solutions. It's not meant for it. So please don't use this as a replacement for your backup. So that's one key message that we want to send across. And both of these are version agnostic. So you can use this from your SQL on-prem, which is, say, SQL 2019 or SQL 19, and then create a DACPack and then import it on your SQL DB. This is how it looks in the portal. So if you look in the portal, and then let's say if we connect to the SQL instance, and then in the SSMS, if you expand to tasks, you have the DACPack options, which is the green bound box, and it has a bunch of options. So it gives options to extract, to deploy, register, so on and so forth. All of them come under the package for the DACPack. Now, for the Backpack options, you have two, so export and import, which is pretty much what customers typically tend to use it to get the data out of SQL DB and then back into SQL DB. This is the one that I was talking about. So this is a new SQL package that we introduced. So this one, with this, we expose two APIs for extract and publish, and this uses the Parquet support. So currently, we support it for SQL MI and SQL 2022, and we have active plans. I don't want to commit on dates, but we have plans to bring it to SQL DB as well. This, for a very long time, has been a problem, right? I mean, if you had databases that were bigger in sizes, we all hated Backpack, the import and export, right? Anything above 200 GB is when SQL export import service will fall flat on the face. It uses the same DACFX APIs. So what we want to make sure is, with the new SQL package, currently it's available in public preview. So you can use this, and if your supported storage location is Azure Storage, you can have files in Parquet, import it into SQL DB in SQL MI, or use SQL MI and then export it into SQL Azure Storage, right? And this is a replace. I mean, this will make sure that we have done some tests for a terabyte or a multi-terabyte databases, and this is very promising for us. So with no commitments on the timelines, we want to make sure that we get this technology even for SQL DB as well. So that way, long gone will be those days where we get frustrated after the DB gets bigger than 200 gigabytes, right? Today, it's a command line interface. So SQL package is a wrapper around all the DACFX APIs. So we have the APIs, but then in order for us to make it easy for you to use those APIs, we build this nice utility. It has all the command line options. It's a command line utility, works cross-platform. Use this to extract and import or interact with your SQL databases or SQL MI or any other flavor of SQL on-prem too. This is how it looks like. I mean, for someone who hasn't seen what is import-export and how does it look like, if you connect to a SQL server in the Azure SQL, and then if you look at the options, there's an option to import database. And then once you import, it gives you an option to select the backup. So this will actually talk to Azure Storage, let you select Azure Storage if you have a file sitting over there, or let you select the destination where you want to dump your data into Azure Storage. And then once you kick off the job, you can monitor the status of the job in the import-export history, right? It's pretty simple. I mean, when we introduced import-export service, at that time, there was a need that how can we let customers integrate data from SQL DB to other places? And at that time, when we created this service, this is a multi-tenant service, meaning we host a bunch of VMs on behalf of you, and we use DACFX APIs, and then we call the same import and export command lines. from our side, and then we run it. Now, the only problem with this service was since it's multi-tenant and we absorb the cogs, it's not scalable. I mean, it's not scalable in the sense one DACFX falls flat after 200 gigs, and that's when a lot of customers, when they started using it, they said, hey, it's good. Initially, when they started in SQL DB 10 years ago, but now as the DB sizes are getting bigger, with hyperscale, we have like 100 terabytes, right? It doesn't cut the bill. I mean, you cannot use this to export a 50 terabyte database from hyperscale, right? But it still works for cases where you have a smaller database sizes and you want to integrate it, get the data out from SQL DB, right? Yeah, so this is the service that I was talking about. It's multi-tenant. It uses the publicly exposable, exposed DACFX APIs. Most of it is an async operation. So the thing that we have heard loud and clear from customers is you submit the request, and then you get the request job. But because of the nature of multi-tenancy, and then it depends on the number of jobs that run, we at times have to throttle these jobs. So you will encounter scenarios where I submitted a job, the job doesn't progress for a few hours, and then it picks up. So those are all the cases where we have seen what's going wrong with import-export. But we are trying to make sure that how can we make it robust, and you get to a point where when you submit a job, it does finish without any errors. Right? It supports Entra ID, which used to be the AAD. It also supports private link. So this is one of the feature asks that was from a very large number of customers, where customers were saying, can you enable private link for import-export service? So that way, everything is in private link. You don't have to have a public IP exposed for your SQL DB resource. So that's supported. And here's the tip. Like if you look in the bottom bullet point, one of the things that we have been telling customers is if you need control and if you want to make sure import-export just scales perfectly for you, use your own resources. I mean, there's nothing that stops a customer to create a SQL VM or an Azure VM and then run the SQL package and then export it. So that gives you better control and gives you more reliable results of exporting the data out of SQL DB, right? So that's one workaround until we fix the problem with import-export service. Some of the limitations and workarounds, right? So this is something that we have seen with many customers saying, hey, what do we do if we have to deal with two-factor authentication, which some customers have asked, because of the sensitivity of the data, we don't want anyone to just export it. How can we set up multi-auth for a SQL export or import, right? In that case, the workaround is to use SQL package. We anyways use the same DACFX APIs behind the scenes, so there's nothing that stops you doing it from on your end too. We talked about the DB limit, which is a 150 gig limit. But yeah, if anything gets bigger than that, then you obviously fall into those scenarios where it becomes really harder. Like for a multi-terabyte database, this is not the way to go, right? It doesn't support importing into Elastic Pool, but that doesn't stop you to get into Elastic Pool if you want to get there. So you can still get it to a single DB, and then from single DB, you can do an online migration, online update, and then import it move it to a SQL Elastic Pool, which is again easily supported. For backup storage redundancy, this came up with few customers where they were saying, hey, when we create the DB, we cannot set the redundancy. What's the workaround? So you can pre-create the database with all the settings that you want, and then use that DB as a destination when you're trying to import it, and then point the files from your Azure storage. So that way, it helps you to get the data into the destination DB with all the settings that you intended for. And it supports SQL authentication and Entra. It's not compatible with the AAD application registration. This is something that some customers have asked for. We have it in our backlog, and then we'll get to it. Any questions on import and export before I switch gears and switch to the next topic? OK, all right. DataSync. So this is, again, one of those technologies which has been around in SQL DB for a very long time. How many of you have used DataSync at all? No? OK. So this is a quick intro on what DataSync capabilities are. When we introduced DataSync, so this was a DataSync.NET framework that was already available, and we exposed it in Azure SQL DB. So this does a bunch of things. One of the things that it does is, I'll show you how it looks like in portal. So that way, we all level set our understanding on what it is, how does it look in the portal, right? So if you go into the portal, and then right under data management, you have replicas, which is for DR. And then you have an option called sync to other databases. And then this has three options. So it has this option called sync group. You give it a name for a sync group. And then there are agents. I'll talk about agents in the next slide. And this is how it looks in the portal, right? And when you click on a sync group, just looking at the properties, you have a name. You give it a name to a sync group. You have your metadata database. So DataSync, by nature, needs to have a dedicated database, one per subscription in one region, where it stores all the metadata. So it notes everything about who is the hub, who is the spoke, and all the details, right? And then we have these options to set automatic sync, and then set frequencies. You can go as low as 5 seconds, right? And then it also gives you an option to do conflict resolution. End of the day, what DataSync gives you is an option of the notion of hub and spoke technology. Your hub is your SQL DB, and then your spoke could be anything, right? Your spoke could be your on-prem database, so you can have data changes in on-prem, syncing to Azure, or the other way too. So you can have bidirectional syncs. Very powerful, helpful for scenarios where you have a niche case where you still have your on-prem sources, you want to sync data to Azure, and you also send it to bidirectional. And if you have dealt with replication, then you will always think about, hey, what happens if there is a conflict, right? What if there is one hub and multiple spokes, and everybody updated the same records? You have the conflict resolution too. So you can specify who wins. Either is it the hub or any of the spokes. Whoever has the first update, they get to win. In that case, it's very powerful, but one of the cases that what we have seen with customers is it gets really complicated and messy if you're trying to deal with multiple hub and spoke. So if you have a case, if you have a use case, start simple. Don't get overboard with adding too many, the hub and you have too many spokes. So start with one hub, one spoke, try to deal with your first use case, and then slowly you can expand to other use cases, right? And when you click on databases, you will see the DB, right? So I talked about hub, which is your central database, which has to be Azure SQL DB, and then your member database. So your member database could be within Azure, or it could also be in on-prem, right? So you can have this interesting use cases where you can have the databases within Azure sync among themselves, or you can have your on-prem versus Azure mix and match, right? What you can do today with Azure SQL DB is SQL DB can be a subscriber for replication, but it cannot be a publisher. So this gives you a neat option where if you want to send changes from SQL DB to another, use this as a mechanism. And this is one of those use cases that it will help you to send those data. And it also gives you controls on the tables, right? So you get an option to choose what tables that you want to sync and what columns you want to sync. So it's more granular, as in if you have a use case where you want to send a particular columns from few set of tables, this is the way to go, where you don't want the whole DB to go from A to B, right? Any questions here before I quickly jump on to a summary slide for sync? Yeah.
So on the spoke, if you've got a table, you do not want any changes to be replicated back to the hub, is it possible to enforce that in some way?
Okay, the question was, how do you prevent changes from the spoke not be replicated into the hub? Once you set up the sync, I mean, when you set into the properties, you will pretty much go into the scenario where you want to say, you select the tables and the changes. There is no way to say changes from the spoke should not go into the hub. But you could have a scenario where you can say the hub wins if there is a conflict, right? In that case, the only option, the only option is either not to enable data sync, or you can say the hub wins if you have a risk that, hey, the spoke should not be the one that should win in this conflict. Yep. There's a question on screen.
Can you use this to publish an Azure SQL DB to a managed instance?
Yes. So the question was, can this be used to sync between managed instance? Yes. So one of the spoke database could be a SQL managed instance as well. That's possible. All right. Moving on, quick summary slide for DataSync. As we talked about, I know a lot of folks might not have dealt with DataSync, so instead of putting this as a first slide, I walked you through how it looks in the portal, explain the key concepts, and pretty much this is a repeat of what we just discussed. Use cases that we have seen is what we have talked about. It's all about hybrid, so customers use it for hybrid synchronization, if you want to use from on-prem to Azure, or distributed applications. So they will have an application where they would say, here's my primary, here's my secondary, but I don't want the entire DB to get replicated. I only have a specific use case where I just want to send data from one table, and SQL DB cannot be a publisher, so there goes. So this is one of those things that comes in handy when you have those niche cases where you just want to send one table or a few columns in a table to any distributed location within Azure. Best practices, there are a few things that we clearly documented in our docs where we say, hey, make sure that your sync groups You look at the compatibility, there are some restrictions that it comes with. Since it does data sync between tables and data columns, so there are some restrictions on the number of columns or the data size. So it should be used only for cases where you know exactly what you want to do, rather than just enabling it for your DB, for your table, and expect it to happen magically. So it does come with some of the limitations. I did call out some limitations here, but I'll point you to that doc link where we have a detailed section on what are the restrictions and limitations that it has. Any questions before we switch gears? Yep, one question. I'm sorry, I didn't. Okay, so the question was, does it support external tables? Not for DataSync. So we do have plans to get external tables within SQL DB, but it doesn't support sync between external tables. So the table has to be a native SQL database table. Right. All right, if there are no further questions, I will hand it back to Carlos. Go ahead, Carlos.
All right, thanks, Rajesh. So I will be talking about a few topics that are similar to Rajesh explained us how you can deal with data portability in Azure SQL Database. So let's get started with change data capture, or known as CDC. How many of you are already familiar with CDC here? Okay, great. So bunch of folks. So CDC, for those that are not familiar with CDC, CDC allows you to capture all those changes happening in a database or in a specific table. So you can capture, as it's on the slide, insert, update, and delete activity. And how CDC does it. So CDC reads from the transaction log, and we have a few processes that I will describe in the next slide that will capture those changes and will insert that change data into what we call the capture instance. So that's a dedicated table for tracking purposes that you can query using T-SQL. So that's the way your application or maybe your processes can consume the change data through the relational model. One call out there that while CDC is very powerful and very useful, you need to test your applications properly, because it adds on overhead, because it's reading the log and it's also using this write back mechanism. It uses the source database to also store that change data. So it creates this change tracking table in the same database. So that's something that we call the write back. So please keep that in mind. This is how it works for Azure SQL Database. As you can see, you can have one or more source tables. So you need to start enabling at database level, and then you decide, okay, I want to do it for one, for two, or more. You can do it for all columns, for certain columns, so it's pretty flexible. It reads the transaction log, as I mentioned, but once you enable CDC, excuse me, we'll have this change data capture table, and we have a few processes that run something we call the scheduler. That's a process we manage, so you have to do anything. And the scheduler will be running the capture process, and this process will be reading from the log, and then we have the cleanup. The cleanup is very important. By default, it's 3 days for Azure SQL Database. It's flexible, you can change it, but we recommend to stick with default because sometimes those tables can be very large. And then finally, once the changes are read from the transaction log and move to the change tracking table, you can consume it using T-SQL queries. So pretty straightforward, as you can see. What are the use cases? Here is like a summary of the different use cases that are very popular among our customers. I can say that the most popular one is ETL. So CDC is like broadly used for in capturing incremental changes for ETL processes. So for example, you have this daily load job that is reading from a table, so you don't have to do it every day, right? So from the scratch, excuse me. So you can have CDC to just catch up the changes for the day. So you can have timestamp and multiple processes around that. So you can see auditing is great because you will get like every single change on your database. So plenty of use cases here. So I included change tracking in this presentation because when we talk about CDC, sometimes there is like a confusion about Do I have to use CDC for my application, or do I have to use change tracking? So what is change tracking? What makes change tracking different than CDC? So change tracking is a lightweight way to track changes on the database. But as you can see there in the third bullet, it identifies the type of change. So it's metadata about your changes, and it also provides you a way to track when that change happened. So you can understand what was changed and when the change occurred. So it's basically metadata about your changes. So it's a little bit different. It has other use cases that I will summarize in the next slide. But as you can see, each table that you enable with change tracking will have these version column. So your table will be evolving, and you can query those versions, and you can understand how the metadata or the changes has been made to the table through this metadata. One of the things that it's like a requirement is that it requires this periodic cleanup. So the same, remember I mentioned this with CDC that we have this cleanup process. The same is for change tracking. So we have this process that will be removing all the outdated information. Here's some of the use cases. It's also great for auditing. I'm not saying that this is going to replace an auditing solution by any means, but it is really good because you can understand at least when was the change made and what was the type of change. The event-driven application is probably event-driven architecture. Sorry, is probably the most popular application around change tracking, because once a change is made to a table, for example, I don't know, maybe let's talk about a price, stock price. Maybe the stock was like really high, and then it starts dropping. So that change on that table can trigger something else. So you can combine these with different things. And we have something new that we just announced last week. And we have the Azure Functions trigger for SQL, for Azure SQL. So you can build very powerful applications to help you shape event-driven architectures with change tracking, combining it with Azure Functions, for example. All right, so here's this slide that compares at very high level CDC against change tracking. So you can see that the first bullet is what tells you what's the difference, right? CDC tells you how the data has changed. It's a mirror of your source table, so you have all the different changes that are current there, and you have the DML operations with timestamps. For change tracking, it's different, right? So it gives you the rows and columns that have changed. So it's not the data, it's just the metadata. And the same way, you can consume this information using TSQL queries and using specific functions that are built in both features. Um, so before I jump into the next topic, is there any question about change tracking or CDC? Oh, go ahead. Yes, please.
So, so does all this take place on the same database, or there are more than one database involved?
So the question is there like one database or more database involved for change tracking and no, so it's just one database. So you enable CDC or change tracking at database level. And all the changes that are happening for the tables you enable with CDC will be captured in this capture instance table that I mentioned. So it's a single database. Yeah, the scope is single. Yeah. Any other questions? Okay, we're good. All right, so let's jump in. I had to set the foundation about how CDC works because I know this might be familiar to you. So we have new feature introduced. It was back in Ignite last year. So we call it Azure SQL Database Mirroring in Fabric. And this new feature was introduced due to the feedback we received from customers. And that feedback, as you can see here, there are like multiple scenarios about today's data and analytic challenges. The first one is the scale of the data. So the scale of data is growing and growing. For example, last Gartner study says that during the upcoming 3 years, the amount of data we are collecting will be three times or 10 times more than the, no, three times more than the past 10 years. So data is growing. We're collecting more information for analytic purposes, for insights about our businesses. So we get this state right now. So you see that right here, there is a growing adoption of BI, and there's a lot of requirements. So the more data, the more requirements we have. And here's a snapshot of the current enterprise data state. You see that we have multiple applications, databases, data warehouses, and different sources producing data. And there are many ETL processes. ETL goes for extract, transform, and load. So these processes will take that data from the source, will transform the data, and then load it to an standardized data like place, if you will. So that's how it works. And then you have the analysts, sorry, the data scientists, and more people trying to consume that data and use it. But you can see that it's very difficult because you have multiple sources, you have multiple processes, it's time consuming, and that's exactly the feedback we received. So, and this takes us to this. So that scenario you saw before is cumbersome, it costs money, and sometimes it's not real time. And you can probably help me here, but how many of you have heard that before from your customers? Like, okay, it's good, the ETL process is here, but most of the time they're like missing data and I need to query the source directly. How many of you have heard that before? Yes, right? It's very common, like sometimes happens. So that's why we introduce mirroring. So as you can see here on the right hand side, we have the value proposition of mirroring. And what is mirroring helping against to move away from those silos, from those ETL processes? It enables you to replicate your databases without ETL. So we support multiple sources today. So as you can see, we have Cosmos DB, we have Azure SQL Database, and we have Snowflake. Once that data is replicated, it will be stored in one lake, so you can do near to real-time analytics. So that's very important. It's near real time. Once you have your data in one lake, you can use all the different services that are available in Fabric. You see that we have Data Factory, we have Synapse Data Engineering. So it's very powerful because you can take advantage of the whole Fabric platform. Lastly, as you can see, this is, and you will see it on the demo, but the idea here is that we are going to use your operational database and put it on one lake. So you will be protecting your operational database from those ETL queries, and you can use one lake for many different purposes. This is like a mirrored copy or a replicated copy of your database in one lake that uses the Delta Parquet. So it's very powerful. This is how it works behind the scenes. So right now, because this session is about Azure SQL Database, you see that we have Azure SQL Database in the left-hand side as a source. Then we have this process we call the replicator that is constantly monitoring your database for those incremental changes as insert, updates, deletes, and those changes are replicated into Delta Parquet in one lake. And then, as I mentioned in the previous slide, excuse me, you can use different services from Fabric as Synapse Data Warehousing, Lakehouse, Power BI to use that copy of your mirror database. And if you want to do queries, we have an option. We have what is called the SQL Analytics endpoint that will allow you to do T-SQL queries against this Delta Parquet data. So let me show you how it works. So let's see, yeah, we have time. So let's do this demo real quick.
In this demo, I'm going to show you how to configure database mirroring for Azure SQL Database in Fabric. So as you can see, I have a database, call it eCovers. This database was created in a general purpose serverless for BigCore service tier. This database is an operational database. As you can see, I have it on CPU. activity here. And this is because I have an application that is connected to my database injecting some synthetic workload. On top of that, I have this Power BI report that is pulling sales information from the sales table. So as you can see, the situation here is not convenient because I'm mixing operational with analytics workloads. And here's when having a mirror copy of your database in Fabric can be helpful. So let me show you how you can do it. So from your workspace, you simply click on New, then you click on More Options. Then you simply navigate to the Data Warehouse section, and then select Mirror Azure SQL Database. Then you have to give it your mirror database a name and click Create. As you can see, I don't have to provision anything. I'm just giving it a name, and then the next step is to connect to my database. I already completed this step, so I'm going to simply select my connection string, and that's it. From here, I have the option to mirror my database like entirely, or if I switch this off, I can select one or more tables to mirror. But for demo purposes, I'm going to continue with all tables. So I'm going to simply click Mirror Database. The mirroring process has been completed, and now I can simply click the Monitor Replication button to learn more. So as you can see, I have this table, the products table, that has more than 165,000 rows. I can verify that's very simple, just running exactly the same query just to get the count from Azure SQL Database. And as you can see, I have more than 165,000 rows. That confirms that I have the same amount of rows. So I can kick off my ingestion processes to ingest data from Azure SQL Database into my mirror copy, but at the same time, I can create new objects as this employee table. So I just created a new table in Azure SQL Database, and let's refresh the schema. And it's called employee, has just sample data about my employees. And what I would expect is the mirroring process to pick up this new table that I created in Azure SQL Database and create the same in my mirror copy. Okay, so let's go back to monitor replication again and focus on the products table. And I can see that the number of rows now is larger than 165,000. That means that the data ingestion that I have for this individual table is being mirrored. And also I can see the employee data. I think the new employee table being created here. So that confirms that mirroring is actually replicating all data without any intervention from me. No pipelines, no ETLs, nothing. So let's take a look at how we can get the most of these, creating a Power BI report using this new mirror data. Okay, so from my SQL Analytics endpoint, I'm going to select the products table and then new report. And from here, I am going to manage my default Power BI semantic model, and I'm going to select the products table and then click confirm. Now in Power BI, I can use the power of Copilot to help me building a new report using this semantic model. So I can just simply click and suggest content for this report, and I can do some product sales analysis, and I can just simply click create. So as you can see, Copilot has created this Power BI report that provides me with the information about my sales performance analysis. And now I am using my mirror copy on Fabric, so I'm no longer using my operational database for this. And this is how you can configure and get out of the most of mirroring in this demo.
Oh, sorry about that. So yeah, just wanted to pause the demo there. That was it. One thing that you notice there that I didn't create any ATL process, as I mentioned in the video, no data pipelines, and the value proposition of mirroring is that once data is replicated into one lake, you can use the different services in Fabric to get the most out of it. In the example, I created this Power BI report using the data in Delta K, and I even use Copilot for that because I'm not a Power BI expert. Is there any question about the demo? Anything else you would like to know? Okay, yeah. In the mirroring process, can you filter a table out? Yes. So the question is, two questions, right? The first one is, can you migrate one or more table? One good. Okay. Uh, could you please repeat that again because can you filter out deletes? No, no, no. This mirroring doesn't have like capability to um, select what kind of DML processes you want to replicate. No, you can select multiple tables, one or more tables, of course, but no, you cannot control that level. Yeah. Any other Go ahead. Yes.
So near real time is very promising. Can you put some more words on what that actually means?
That's a great question. So yeah, near real time is the question is, can I get more inform or share more information about near real time? As of today, this product is still in private preview, so we are learning from the feedback from our customers. Near real time means that we're doing our best to catch up. That's something that was on one of the slides. That once the initial snapshot is done and the database is replicated, we have this replicator that will be constantly monitoring the changes on your source database. It reads from the logs and it replicates the data to one lake. So as of today, we are committed with the near real time. We don't have a specific number yet, but as the feature like evolves, probably we will get more and more information, yeah, about it. But right now, I can give you a really good answer about it. Yeah, unfortunately. That was another question. Do we have plans to support on-prem SQL Server? It's on the backlog. Yeah, we have multiple requests from different flavors of SQL, but yeah, it's in the backlog. Right now, as of today, SQL database, Snowflake, and Cosmos DB. Yeah. Any other questions? Yeah, go ahead. It is possible to mirror a view to a table. Not today, but that's also some very valuable feedback we receive from our customers, and we are like analyzing about this, like because replicating a views, it's I would say it's not straightforward. It would be easier with materialized views because it's a real table. And I believe there was a question about external tables, for example. As of today, we only support like regular tables with primary keys. You can read more about the limitations in our documentation, but yeah, that's one great request we get from our customers during the private preview. Yes, go ahead. All right, so the question is, can you change this table structure after you start mirroring? Okay, the question is how it works, right? So yeah, if I go back a few slides, let me go back here, right there, that one right there. Yeah. So once the process like starts, it creates this snapshot. So it takes a few seconds to create the snapshot, and then all this data is mirrored into the copying delta. Once this process is done, we have this other process in the replicator that will be constantly monitoring the table for all the changes. So while, let's say at CDC, I mentioned that, right? So there will be an insert or maybe a delete. Those changes will get replicated near real time to the Delta Parquet copy. Yeah, that's how it works. Okay, there we have a question on the screen. Oh, sorry.
Can we change structure of mirror tables?
Can we change the structure of mirror tables? Yet, at some degree, we have the limitations documented. There are a few modifications that are not supported yet. DML is supported, DDL is supported at some degree. You see me creating a new table, so yes, at some degree you can change the table. There are a few operations that are not supported. Yeah. Yes, please, the question.
Yeah, does mirroring use change tracking or CDC?
No. So the question is, does mirroring uses CDC or change tracking? No. Mirroring uses a different technology. It reads from the log, but it is not the same technology. That's why I wanted to explain that first. Yeah, It is a different proprietary technology it's completely different, new, brand new. All right. So we have 5 minutes left. I would like to um, sit spend some time with this demo in this demo excuse me, in this slide because it summarizes everything we talked today. So you can see it in overall. We have like the scope in the left hand side for which technology is best used, right? So depends of your use case, you can select the right tool for the right job. So probably there was one question about migrating one table. Probably that won't be a use case for mirroring. That will be a better case for DataSync, as Rajesh explained it to us. So I will let you to check all this information here because, of course, we cannot go and explain every single thing. But you can see that different tools are available for different um, offerings of SQL. Most of them are in for everything. Mirroring is the one that is only available in Azure SQL Database here. So yeah, different tools for different purposes. So that's kind of message. Depending of your use case, depending on how you want to move the data from on-premises to Azure SQL Database, you have different tools at your disposal. We have many resources here listed on the slides. You can see that we have resources for CDC, change tracking, for mirroring, for import-export, and data sync. We have 4 minutes left, so I would like to leave this slide. I'll be back to you. I'll leave this slide for feedback, so if you can help us fill in that survey. And yes, we have another question. Go ahead, please.
Can you mirror a managed instance?
Say that again, sorry?
Can you mirror a managed instance?
Managed instance, no, it's not supported today. But as the gentleman asked, we are like, we have few sources. Yeah, we have a few sources in the backlog. I can say that. Yeah, we're working on it. Yeah, we're definitely working on it. Any other question? Yeah, go ahead, please. Yes, mirroring is still private preview. Uh, it is scheduled for Q1 2024, so it's coming. That's all I can say. It's coming. Yeah, Q1. We're still in Q1, so it's coming very, very soon. Soon as you can imagine.
One more week for Q1 to end.
One more week. That's all I can say. One more week for Q1 to end. Q2. Oh, okay, Q2. All right. So Q2 is the, the commitment. Um, all right. Any other questions? We have 3 minutes left, so I think we can close. We would like to give this away, but I would like to ask a few questions if you don't mind, and I can just give away for the fortunate person that can answer the question. Does anyone knows which are the different sources that we support today for mirroring? Anyone would like to say? You?
Is it for previous today as well?
For what?
If it is for the preview, it's SQL DB, Cosmos, and Snowflake.
That's correct. Yeah. Lucky winner.
I'll ask one question. I don't know if
Go
I'm
ahead.
audible. So can you hear me?
Uh,
Can you? So
There we
one
go.
question. So can DataSync be used for migration from on-prem to Azure SQL DB? I saw that gentleman saying no, so you nodded. You are not confident, but I like your confidence. Please, thank you.
I'll
Yeah,
ask him.
please, that was a question online. So someone was saying, can we use data sync and replication for migration? Yeah, these technologies are not for migration.
Mhm.
You cannot use data sync to migrate your on-prem. Use it only for synchronizing changes, but not for migration.
We have a question on the
Yeah.
screen.
Yep. What is the overhead of mirroring on the source database?
What is the overhead of mirroring? That's a great question. We're still. Oh, I don't know. I'm audible.
Yeah, you are.
All right. We're still working on that. I can say that is probably 15 to 30% of overhead right now. But that will change. Right now we're in still private preview, working on improving and getting more feedback from our customers. So
Yeah, one last question. I think, so comparing for data export import, when we said if you want to have better control, do you think you should create an import export job or you want to run it on yourself? Yes. That was a easy giveaway because I wanted to give away the socks. Thank you. Yep. All right. Hope you've enjoyed. Thanks for your time. I hope you learned something new from this. Yeah, thank you.
Yeah, thank you.
Yeah.